Welcome back, everyone. The last time we started talking about basic concepts of sets. Now we're going to talk about subsets. And I think I've got a pretty good example for you that will help you along the way. So here we go. Here are some of the things we're going to talk about. In particular, some notation. This notation and that notation. This one, by the way, refers to proper subsets. This is just subsets in general. They're very close, but there is a difference, and I'll explain what that difference is. So here is a subset. Now this means A is a subset of B. And I've got an example that I hope will help you. First of all, it means that anything you see in here, you can see in B. So B is like the master set, and A has some of the items of B, or none. But everything in A can be seen in B, because this is your starter set. This is a new set that you form by maybe taking some elements out. Now here's an example I'd like to use. So you like to do things around the house, and one of the tools you use occasionally are pliers, and sometimes you use a wrench. Sometimes you use a knife. And let's say sometimes you use a hammer. Okay, we've got 4 tools that we use. This is our master set. So this is like B. Now think of this as your favorite set of tools. But you've got a friend that occasionally borrows from you. Every Monday he comes over and sometimes borrows some of those tools. After Monday night, you go down the next morning, and what's left is set A. Now it might have all of those. They might all be there. Maybe your friend didn't need to borrow any of your tools. It's still a subset. Or maybe this time he's borrowed a wrench and there are 3 left. It's a subset because the ones in here already started in your master or your favorite set of tools. Sometimes your friend will be very ambitious and maybe borrow all the tools. What's that mean? Well, that means that what's left the next morning is nothing, the empty set. Or use this if you like. It's still a subset of the original set. So when you think of these sets, put the B first, put that down, because that's what you start with, and then your subset and subset notation, and here's your subset. If you can see it in here, you're guaranteed you're going to see it in here, because this is the set you started with. Some might have been taken out, and you end up with a subset. I hope that helps a little bit. The only other change or addition is if you put a mark through it like this, that means it's not true. It's not a subset. 2 notes. First of all, every set is a subset of itself. What does that mean? Well, you started with set B, right? And B is a subset of B. Well, that looks a little bit silly, right? That can't be true. Well, think about it. The definition says anything from the set over here is in the set over there. Well, of course. If it's in set B, it's in set B. Real simple. So that means every set is a subset of itself. There is another possibility that seems sort of silly, and that is the empty set is a subset of any set. No matter what this is over here, the empty set is a subset of any set that you put here, even the empty set itself. Let's take a look at this and see if we can answer the questions. Write either is a subset or is not a subset in the blank to form a true statement. So let's take a look at these. We've got A first, B second. So this is our start set. We want to see if everything we see in A we can find in B as well, because that's what we started with. Maybe took a few out, and this became our subset. Well, look, there's 1. It's over there. Check. So far, so good. 3 is over here. 5 is over here. 7 is over here. That's all we need to know. Everything in this set can be found somewhere in here. Since that works, then we can write in A is a subset of B. Next, let's take a look at a slightly different one. This time A and B are a little bit different. Set A is the set of all X such that X is a letter in the word proof. Set B is the set of all Y such that Y is a letter in the word roof. Now, what we want to know is, can we put this between those letters, or do we have to put a line through it? Let's check. What is in A? We've got P, R, O, and F. Remember, it's a set. Writing O twice doesn't make any sense, because either it's in the set or it's not in the set. Set B, what does that have? It has R, O, and F. Let's check it out. Is everything that we see in A also in B? Check out the P. The P is not over in B, so immediately it's not. There we go. Next, proper subset. Very close. Proper subset just means that from your master set, if we talk about sets A and B, here's like the starter set. Everything from A started out in B. There might be some extras, there might not. Proper subset, written like this, means that when you created this set, you took at least one of the elements out of B. At least one. So, for example, let's suppose B contained the numbers 1, 2, 3, 4, and 5. B is not a proper subset of B because there's nothing missing. Now let's create a subset A. Take one or more of these out. Let's say what's left after we play around a little bit. 1 and 2 and 5 are there. Is it a proper subset? Well, first of all, it's a subset because 1 is in the original set, 2 is in the original set, 5 is in the original set, so it's a subset. Is it a proper subset? Well, proper subset means there are some extras in the original set that are not in the new set. So it's a proper subset. A couple of questions here to check. We want to find out which of these or both is true. So set A is persons living in San Francisco. Set B is the set containing the people who live in California. Is everyone in this set also in that set? Well, San Francisco is in California, so it's definitely a subset. Is it a proper subset? In other words, are there any people we haven't listed in San Francisco that live in California? Well, very simply, you can say, how about San Diego? I know a guy named Charlie that lives in California, but he's not in San Francisco. So there are some extra people that don't live in San Francisco. So this is a proper subset. Second one, A and B. What do we have? A and B. So we'll take a look at A. First of all, is it a subset? 2, check this one. 2 is also here, good. 4 is also here. 6 is also here, so far so good. 8 is also there. Good, so it's a subset. Is it a proper subset? Is there anything in B that wasn't in A? No, everything in A is also in B, so it's not a proper subset. So we won't put the equal sign underneath that. Next, the empty set. It can be strange at times, yes, I understand. First of all, for any subset, the empty set is a subset of it, period. For any set B other than the empty set, in other words, if there's anything in B at all, then the empty set is a proper subset. So, for example, let's say B has 1, 2, and 3 in it. It has something in it, so the empty set, or let's write it this way. The empty set is a subset of B, 1, 2, 3. Since B has some elements in it, then this empty set is a proper subset. You can find something over here that isn't in the new set. You might have to think about that for a little bit. Maybe when you're out take a walk or something, just think about the empty set for a little bit and subsets involving the empty set. Now, we're talking about how many subsets it has. In other words, you start with a set. Let's go back and let's just take something simple. Let's suppose we've got a set that has 1, 2, 3, 4, and 5. And let's say this is set M. Set M contains all the things you can use to make a new set. So if this is set P down here, we can use any or all of these elements from M. So how many ways can you do that? That's what we mean by number of subsets. You start with a certain set. Using that, how many sets can you create? So for example, down here, we're starting with this set. How many subsets can we create from it? We can create the empty set, that's a subset of everything. You can just put A in it, that's a subset. A and B, that's a subset. Bunches of sets. Now, how about subsets? Well, the first thing to notice is how many elements are in the original set. In the case of the empty set, there are no elements in there. In the case of the set containing A, there's only one element in there. In the case of this one, there are two members in there, and this one has three. Now, how many sets can you create using one of those as your original set? Well, here's a formula you can use. Number of subsets is 2 to the n power. Oops. My apologies there. Computer went nuts for a while. Here we go. Okay. 2 to the n power. And n represents this number right out here. How many elements are in the set? This will give you how many subsets you can create from that set. So you can see in the table, if you have 0 elements in your set, you're only going to create one subset itself, the empty set. If you've got one element, you could have that set, or you could have the empty set. You've got two. This one is 2 to the 0 because there are no elements in that set. This one has one set to begin with, so this is how many subsets you can create. And this one, there are 2 elements in that set, A and B. 2 to the second means you have 4 subsets you can create. And if you've got 3 elements, you can have 2 to the third power, or 8 subsets you can create from that. Now let's take this one for a quick example. Here's your starter set. What can you create from that? Well, first of all, the subset, the empty set is always a subset. And since this has 0 elements, how about the ones you can create with 1 element? You could have just A in it. Could you create anything else? Sure. You could create one that has just B in it. So 0 elements in this line, 2 or 1 in this line, and you can also have that set. 4 in total. The empty set, the 2 sets that have 1 element each, and the set that has both elements, 4 elements. So just count the number of elements in the set, use that as your power of 2, and that'll give you the number of subsets. Now, there is one little trick, and you can get this real easily. If you want the number of proper subsets, the only one you have to throw out is the original set itself, just 1. So if this is 2 to the n, just subtract 1, and you've got the number of proper subsets. Very simple. Remember this one from the number of elements in your original set. And if you want proper subsets, just take 1 away. So how about this one? Find the number of subsets. First of all, how many elements are in this set? You've got 5 elements. So how many subsets would you have? 2 to the 5th, which, if you do the arithmetic, 32 subsets are possible. How about proper subsets? Well, the only proper subset, or the only subset you can't use, is the set itself. So you just subtract. You have 2 to the 5th, and just subtract 1 from that. So you can have 31 proper subsets. 2 to the n, and just subtract 1 from that number to get the number of proper subsets. Okay, let's take a look at another one. We're looking at the set of all x such that x is a natural number and x is between 9 and 15 inclusive. So how many numbers do we have? Okay, this is one time when I'll let you use your fingers, count them up. 9, 10, 11, 12, 13, 14, 15. So we've got 7 elements in that set. By the way, another way of doing this is 15 minus 9, but that leaves us 1 short. Always add 1 if you're subtracting to get the number of elements in the set. Now, how many subsets? 2 to the n, or 2 to the 7th, and 2 to the 7th will be 128 subsets. How about proper subsets? All you need to do is subtract 1 from that, 127. If you didn't have the 128 to begin with, just take 2 to the 7th and subtract 1. Make sure you don't subtract 1 from the 7th. This exponent has to be used, and then when you get the answer, subtract 1 to get the number of proper subsets. And there you go. We've got the answers. Now we get to something a little bit exotic, and they don't say too much about it here. So remember what the natural numbers are. First of all, we use the capital letter N to represent the set of natural numbers. And what do those look like? Well, remember, the natural numbers are the counting numbers, so if you remember when you learned how to count, 1, 2, 3, 4, 5, 6, and so on. Is there a last one? No. No last one. So this is strange. You can't say the number of elements in that set or the cardinality of it. Remember that? However, there is a special symbol that's used to talk about how many natural numbers there are. And this is a strange looking character. And it's called, I don't do too well with that. This is why I use PowerPoints. This is called Aleph Null. This 0 here is the null part. And this is a, I think it's a Hebrew letter, Aleph. I don't know my Hebrew, do you? But, so, how many subsets can you create from the set of natural numbers? Well, just take 2 and put this number in the exponent. Aleph Null. I think the easiest way to do that is pretend like you're making an N, but pretend like you're a little bit nervous when you do it. And that'll create your Aleph. How about that? And then remember, if it's for the cardinality of the natural numbers, it's Aleph Null. Don't worry about all this. This is a little bit exotic. This is how many natural numbers there are. And this is how many subsets we can create from that. This is the number of proper subsets. There's your subtracting 1. Don't worry about this. This is a bit exotic. This is the cardinal number of the natural numbers. And don't worry about the transfinite things. There are other things we can talk about that are much more important than that. But just for example, n set of natural numbers. There's some numbers that are a little bit different. For example, if you, in addition to having all these, if you also throw in numbers like the square root of 2, because that's not an integer, it's not even expressible with a fraction. It's an extra number. It's called an algebraic number. Throw in the square root of 3. Throw in 7 times the square root of 5, for example. All of those are not in this list. They're not even in the list of fractions. They're transfinite. And then we have some even more exotic numbers, and I'll just give you 2 examples. Your old friend pi is it's called a transcendental number because it can't even be written like this. There's also another one that is a little bit more exotic. You might or might not have heard of Euler's number. Euler's number. It's also one that is not an integer. It's not a fraction. It can't be written using roots. It's beyond all that. It's called a transcendental number. And there are more of these than all of those put together. Now that boggles the mind. Sorry. So while you try to get your mind back together, relax, hit the pause button or stop button, whatever you like. Maybe you want to review the whole chapter again. Just go back to the beginning, listen to it again, and you'll get everything straight. Well, I'll see you next time when we'll expand our knowledge about sets. Until then, you take care.